imaginary units. Then the conjugate. And look, there's a trick here that if you want to find the conjugate, I don't know, you have to make a line on here. Then yeah, then the conjugate of z is a minus bi. Okay, so basically what happens, the sign in the middle, this and this change. Okay, yeah, that makes more sense. Of the z, no, damn it, bro. Indicates that we are finding conjugate, the conjugate. Okay, so that's what the line above means. Okay, so that's, yeah, I just want to clarify that. Like, for example, let's take some examples here. Suppose a is minus 3 and b is 5. Then the conjugate, I'll just write conjugate so it's easier. Then the conjugate, the variable z is widely used in the complex number system to indicate that the number is complex. Yeah, this is also important because I know that I had said this before, but the variable z, it's used commonly because you know that it has like a, because it's just like a, because it are x and y are used for real numbers, you know, like that. But z is special, okay? So that's what it is. So I think this is all about conjugates. And there's one more way, like you would see this, like if you have to add, suppose you have like something like some, we can also like perform operation like here. If you have something like 3 plus 4i plus 3 minus 4i, guess what, this and we're just left with 6. So we can make a general rule. Yeah, sum a plus bi and a minus bi is 2a, like, because if you have something like okay, a plus bi plus a minus bi, so what do you get? This is cancelled and you're just left with 2a. Yeah, and we'll get to the product and stuff later. We're gonna get to that in this video later. Okay, so these are all about conjugates. Okay. So I hope you understand that. You can take a screenshot of this if you want. Okay. And yeah, it's gonna rest there. Oh yeah, one more thing. If you have like something of the difference of conjugates A plus BI and A minus BI, let's find it out. A plus BI minus A minus BI. Remember, the sign changes, so it becomes A plus BI minus A plus BI. Interesting. Now this and this gets cancelled out, and we're left with 2BI. So I guess the answer is 2BI. Is 2BI. Remember this also. What if, suppose if we do something like what if we do A minus BI, let's do vice versa. Let's see what happens if the answer is different or same. Okay, okay, then we get open the brackets, A minus BI minus A minus BI minus A plus BI. Oh, look, plus A minus A minus BI. This is 0. Yeah, look, let's distribute this. Yeah, yeah, because like if you get A minus BI minus A, oh wait, sorry, this thing will here change, that's my mistake. This will actually become A minus BI minus A minus BI. So this will cancel, but this will be minus B minus 2BI minus 2BI. Okay, so and A minus BI minus A plus BI equals minus 2BI. Okay, you can test this with an example. Let's do one. 50 plus 4i minus 3 minus 4i. Yeah, I think, yeah. Now you get what? 3 plus 4i minus 3 plus 4i. 3 minus 3 plus 4 plus 4i. So 2 4i. Yeah, it works. 2 4i. But in this case, 4 is b. Okay. So this is all equal. Okay. So yeah, I think that's all. Okay. Now you can move on to the next topic. I think we should probably do that. Okay. So let me delete all this. Our next topic is an application of conjugates. Okay. Sorry, I'm just a little tired. Okay. Now, you've been reading for this. Division, complex expressions, application, divide, complex expression using polynomial long division and synthetic division, because it's not efficient enough, right? Because now there's another method here. I'm just gonna pull out an example. Okay, suppose we have something like this. I'll give an expression. 3 plus 2i upon 1 minus I. Okay, here's the trick. The trick is multiply numerator and denominator by the conjugate of the denominator. So in the last topic we learned about conjugates. So what this means is that we have to multiply this right here by 1 plus I. And look, yeah. And if we do this, we're going to multiply this by 1 plus I. Okay, first let's multiply this out. So if we simplify this, okay, wait, let's do this on this side. 1 minus I to 1 plus I. 1 to 1, 1 squared, which is just 1, plus 1 into I, which is I, minus 1 into I into 1, which is 1. I, which is I, sorry, I into 1, I into 1 is I, and then minus I into plus I, which is I squared. And now let's simplify this. We get 1 plus I plus minus I plus, look, I squared is negative 1 and minus 1 is plus 1, right? So if we simplify that, this cancels out. I plus minus I, 0. So what do we get? We get 2. Wow, that's amazing. We get 2 here. Yeah, because we get 2 here. So right, we get 2, and now let's multiply this out here. 3 plus 2i into 1 plus I. Okay, same thing. 2 to 1 is 3 plus 3 into I, 3i, 3 into 1, 3 into I, 3i, plus 2i into 1, 2i, plus 2i into I, 2i squared. Let's clean this up. Okay, combined like terms, this will be 5i plus 5i plus 5i plus 2i squared, and 2i squared is what? Negative 2, and so this will be minus 2. Okay, minus 2. So then we get 3 plus 5i minus 2. Okay, now for moving on from here, this has gotten pretty easy now, because now let's divide each term by 2. Okay, so first let's divide this by 2, then this by 2, then this by 2. What do we get? Yeah, this is 3 plus. Okay, so this will be 3 by 2, just like that. This will be still 5i by 2, and this will be minus 1. Yeah, so this is your answer. Okay, this is your answer to the question. Okay, so this was the question. This was the question. Sorry. Whoa. Okay. Yeah, so the question was this. Okay, you have to multiply the conjugate. So the question was 3 plus 2i upon 1 minus I. And the thing is, let's write another thing here. The product of complex number and its conjugate is always real. Is always real. Okay. Okay. Just gonna write here. Okay, cool. So now let's prove this. Okay, this is the answer. I think I should just erase this now because yeah, I cannot. Let's verify. We can verify our result by multiplying this answer by 1 minus I. So I think we should do that. Okay, let's multiply this by 1 minus I. 3 by 2 into 1. Hold on. Into. Let's multiply 1 minus I. Okay, live distribute. Okay, this is some 3 by 2 plus. Yeah, we're just multiplying by 1 by 2 minus plus 5 by 2 minus 1 into 1. This is 1. Okay. Okay, now here minus 3I by 2 plus 5I squared. Yeah. And this is supposed to be negative sign. Hold on. Minus 1. Yeah, this is 3. Sorry. This is a 3. And this is minus 5I squared upon 2. And then plus I. So let's see our result. If we simplify this, look at 3 by 2 plus 5I by 2 minus 1 minus 3I by 2. Okay, I squared is negative 1, negative 1, negative 1 to 5, negative 5. Sorry, plus 5 by 2 plus I, and we need to obtain the result 3 plus 2I. Okay, now let's clean this up a little bit. Where is this? Okay, now if you can see here, first let's combine the real numbers. 6, 7, 8. Okay, this. What do you get here? 8 by 2 plus. Okay, 8 by 2. Oh wait, minus. Yeah, minus 2 by 2. 6 by 2. 7, 6, 6 by 2. Just 3. Okay. So I can get these 3 real terms. Now 3 plus 5I upon 2 minus 3I upon 2 plus 2I upon 2. Okay. So now let's combine this. We're gonna simplify this. We can make this all a common 2 since they're like terms. Okay, upon 2. This whole thing is upon 2. Now 5I minus 3I plus 2I upon 2. Okay. First of all, 5 plus minus 3 plus 2. 6, 7, 7. 5 plus 2 is 7I. 7I minus 3 is this is 4i upon 2, 4i upon 2, this will be 4i, this will be 4i upon 2. I don't know, that's already there. Okay, 4i, yeah, the result will be 4i upon 2. Now if we simplify this, 1, if we divide this by 2, we get 2. And wow, the answer is in fact, the answer we get is equal to 3 plus 2i. So yeah, so in fact, whatever answer we got was correct. Good job to me. I'm so happy now. Okay, so that's about division. So you can do this for all numbers, okay? I think I erased some of that. Yeah. It's a good thing. Alright, so now since our answer is verified, the answer is correct, now let's move on to the next topic. Oh my god, the video is 22 minutes long already, bro. Alright. And now I'm gonna be doing a new topic, which is, hold on, I pulled it out. Okay. Now this is gonna be a little tricky. Okay, let's do this. Now we're gonna start a new topic, which is called polar form. First argument. So now the distance of the number from 0. absolute value, no, or magnitude. Yeah, the absolute value for complex numbers is also known as magnitude. The distance, 2 points A, B, the origin 0 by 0. So that's what it means. That's the distance. The distance, like in the points, if you have A plus BI, these are the points. We can say coordinates. These are also known as the coordinates. Okay. Okay, so that's the point. So look, now we have to recall a formula that we learned in formula. You remember that? Look, the distance hence proved. Okay, that's all the proof. I'm just gonna erase all this. So you have to just recall that. I just want to give you a proof, okay? Yeah, it's nothing too serious, but like, it's just for you to know, cause it could come up. It's for your knowledge, you know. So yeah, like in the like when you saw in the complex plane in the last video, part 2, there's an origin, and it's also the number like in the for real number. There's a graph for x and y axis. There's also that's the distance formula from the origin to the number, and same goes with the number line, the distance from 0 to that number. Okay, now we're gonna do okay. You're solving. Now I'm gonna do a something like this. Okay. Hey, how long is this video? Oh damn, 30 minutes, bro. All right, now let's wrap up this topic. We're gonna do one more topic, which is about complex expressions. We're only gonna do a few today, okay? Because time's almost up. All right. So if you have, suppose you have something like you know, like suppose you have to factor a basic, like, you know, like last time, like suppose you have something like this, x squared plus 1. Okay, we know that this has no real factorization, but we can factorize this. This is by the sum of cubes. I'm just doing a recap. So this would be x plus 1i, which is just I, or we can write this x plus x minus I. Okay, now in today's video we're going to factor actual expressions that have like imaginary like things. For example, if I have something like this, x squared plus 4 plus 4i. So look, if you wanna factor this, we can write something like this. We can write this as x squared plus 2 into the square root of I squared. And this will just become, you know, a plus bi. So a plus, this is the b, 2 times root I, into I into x minus 2 into root I times I. But this doesn't turn out very nice because it's a square root. So I mean, these usually, like, I'm gonna show, like, if we solve something like this, like, we can't use the quadratic formula because this is an I, not x. So it won't turn out well, but I'll show you something that turn out well. If you have something like this, x squared plus 4i squared. Now we can write this as x squared plus 2i whole of 2i squared. Now just write this as factor x plus x plus 2i into I, which is I squared, because a plus bi into a minus bi. Now we can simplify this. So this will just become, look, I squared is negative 1 and negative 1. I squared is negative 1. So this will be plus minus 2. Or then we can just write this as net minus 2. Okay? So minus 2. Okay? And this will be plus 2. Yeah, because this will be plus because there's a negative sign. Okay? So that's how to factor this. Plus 2. That's how you factor this. Okay. Now suppose we have something like a little more, like, now let's try to solve a quadratic equation, something like this. We're gonna use the quadratic formula. Suppose we have something like this, 2. Okay, now we're gonna do a new topic. We're gonna continue factorization because there are some new ones, but I mean they're simple because you have to use the previous knowledge. But for now, I want to use solving quadratic equations that have imaginary roots. Roots mean the solution. Okay. So suppose you have something like 2x squared plus ix plus, let's say this is 1. Because here, and look, how do you know if the 0? The discriminant. The discriminant is equal to b squared minus 4ac. I'm sure we learned this. What is b here? B is I. So I squared negative 1 minus 4. 4 into A and C. 2 into 2. 2 into 1 is 2. And 2 into 4 is 8. So this will just be minus 9. And look. Yeah. And look, there's a thing that if the discriminant is less than 0, there are imaginary solutions. Okay, so like, so that's the thing. I just want to let you know that. Okay, now if you solve this, we're gonna have to use the quadratic formula. Okay, because factorizing, it will be kind of difficult. So we're gonna use the quadratic formula. X equal negative b, negative I plus or minus the square root of I squared, negative the square root of b squared minus 4ac 8 upon 2a, it is 2, which is basically equal to minus I plus or minus the square root of minus 9 with the square root of negative 9, which can be written as 3I upon 2. Now from here we get two solutions. We get negative I plus 3I, so 3I minus I, you'll get 2I upon 2, which you get 2 I, okay, I, and here we'll get minus I plus minus 3I plus minus 3I, which will be minus 4I upon 2, it will just be a minus 2I. So these are our two solutions on how to solve it. Yeah, we can verify it. Let's verify it. Yeah, we don't, yeah. No, we can check one solution. If the one solution is correct, if the other is also correct, like let's see. 2I squared plus ix plus 1. Okay, I squared negative 1, so this negative 2 plus ix plus 1. I know, yeah, we have to plug in x, right? So this will be I squared is plus negative 1 plus negative 1. Wait a second. What happened here? Negative b. Negative 2. Hold on. I squared negative 1. Okay, wait. So this cancels, but we can, there must be some mistake. Okay, what about? Okay, no. Okay, you guys verify using minus 2I. So I'm just gonna end it here because my video is too long, bro. So we're gonna do the remaining topics in another video. Okay. So I'll see you later. Peace. And also check out what mistake I did. I don't know what I did, bro.